Okay. Okay. Hello, everyone. Good evening. Thank you for joining us for this session. Today, we'll be going through sustainable sanitation and wastewater management systems. We will be covering a few broad topics and general concepts. If you want to go to details, it will take a very concentrated workshop. So the slides are based on a book called Compendium of Sanitation. It's published by AWAG. I've shared it to our groups before in Arabic. It's available in Arabic, English, French, and I think also Spanish. So a quick brief about me. My name is Yosef. I've studied architecture in the Arab International University in Syria. After I graduated, I moved to Iraq, where there's competitions that are usually run by non-government organizations, and the winners will get some small funding to start and set up their business. And through one of those events, we didn't win, but we got the support to start a small company named Treatment Hub. We worked on it for a year, then the team went their separate ways. After that, I started working with an international organization called Field Ready. I started as a program assistant, that I was managing the program that were implemented by the organization, keeping up with training activities and program development and a few things there. After that, I moved to more into operation and logistics and monitoring and evaluation. So I covered a broad topic of tasks there. And then at the end of 2021, beginning of 2022, we started me and my friends started Suli Innovation House, and where I have been working as a program lead, basically coordinating the efforts of the staff there to implement training programs and capacity building programs for youth in Iraq. So just a quick introduction how I started working with sanitation. 2019, there was an activity called Eco Innovation Hackathon in Iraq. This is me and the team presenting our idea. We did not win any funding, but our idea was good, so we were offered a traineeship program where for 9 months, where during that, we managed to secure a few contracts to do needs assessments and basically spread awareness about these sanitation systems that we're going to talk about. And after that, we've managed, we worked with the local government. This is us during a workshop with the municipality of Erbil, where we were talking about how to plan decentralized sanitation system. Basically, it's not one central treatment facility for the whole city. It is small, let's say, treatment plants across different parts of the city, so it's not centralized. And after that, this is in the Directorate of Fresh Water and Wastewater in Erbil, where we were presenting the work that we have done so far with the organization that was mentoring us at that time. And yeah, so that's a quick brief on how I got into this. So we're gonna start now with what we can look as wastewater. What is it that comes out of the houses? It's split into different categories. First, we have black water, which is everything from urine, feces, washing water, anything, and storm water. All that is called black water. A little bit inside it, it's called brown water, which is only basically nothing, including water. And we have excrete humans. So along, let's call it a journey. So it starts with basically a user interface, which is the typical toilet that we use. And then it's, depending on the system, there is something that is containment, that this waste is going to being stored in this containment thing. We'll talk more about them later. And then it's emptied, transported, ideally to a treatment facility. That doesn't happen a lot sometimes, but ideally it should go to a treatment facility, and after that it goes to reuse and disposal. And this is in the reuse and disposal part, there is an opportunity for small businesses also to come in and work around that and generate profit. So we're going to start with the user interface. Okay, maybe user interface is something usually linked with apps or websites, but here we're going to talk about toilets. Okay. So the first thing, which these systems are common in some areas in the world, some areas are not using these things. So it's just a general overview of what is there and how is it used. So there is something called dry toilet, which is basically a hole in the ground where you just use it, and there is no need to flush water or anything in it. You just use it directly. These are common, let's say, in places where you have, let's say, a small, like a conflict, a natural disaster, or in remote places that are away from urban centers. There will be like sometimes it's a shared facility between multiple houses. So where just people can use it. And later we will see how what happens after this. Like a different or an upgraded version of it, it's called urine diverting dry toilet. Basically, feces will go, or solid waste will go down its separate way to a hole in the ground or something. You don't need to flush it or anything, but urine is collected and then it goes down a separate way. We will also see this later in the next slides. And the urinal, I think everybody's just familiar with this. And then what is most common in the Middle East, especially like if you go back a few years, it was this poor flush toilet. Everything like this was what was most commonly used. And then right now, the most popular things are the regular flush toilets that are in every house. Everybody knows them. And then there's also a combination, which is also a urine diverting flush toilet. It also takes the urine, goes down a different path than what solid waste goes through. Any questions? Am I moving too fast or anything? The few slides and like next few slides we'll start having more of discussions and questions maybe. Okay. So here's this containment. This is what happens after after we use the toilet, let's say. So if we're using a urine diverting toilet, the urine is usually it goes to and be collected in jerry cans and bottles or something like that. If it's yeah, the dry toilets are directly connected to just a hole in the ground. There's a bit, it's called a single bit. It goes there after a few years, maybe, depending on how many people use it. It's full, you close it, and you move the toilet. Happens a lot in houses that are in remote locations. So where there's no infrastructure, nothing to connect to, that's where they are most common. Or in some poor countries or developing country, this is a shared facility between multiple houses. There was a lot of problems with it, especially the smell. So the next update to it was it's actually they like a small pipe for ventilation was added. So so there is no smell. There's nothing. It's more a little bit more clean. But again, after it's full, you have to move the toilet basically to a new make a new bit and then move the toilet there. And as I said, like if it's full, you have to move it so that you have it. Okay, so let's make just the hole bigger. We split it in two. We use the first one at the beginning, and then when it's full, we move just to the second one directly. And a next update for it here when we start talking about more of reuse. So we started here. All of these that I've talked about, there is no water that goes in them yet. So it's just solid wastes. Then the fossil alterna, which is this system, was a little bit updated, where we started using more of, okay, we don't just use the bathroom, we also throw organic materials there, like let's say vegetable waste, bone waste from, I don't know, like from meat and chicken. It's just thrown also down there. And after it's finished used, it's sealed up with dirt. So there is a process of composting. So if you leave it for a year, it's compost. You can just dig it up and use that compost in farming, and then use the whole again. This is also something that is very common, even in the Middle East, in our countries, where we have the poor flushed pits, which جوار فني, basically, where it's the water and waste goes to it. It's perforated. It has openings in it, so the water will slowly go into the surrounding soil. But also, like with time, it will be filled with solid waste. So this system was, you have two separate bits to use, because these are, you can't, when it's full, you can't just bring a truck or something and pump it and empty it. Another containment system, that's especially for the urine diverting toilets, which you can see here. Okay, it's called dehydration vault. So the urine is going to a tank, and then urine from healthy people is usually sterile, so there's no bacteria, there's no germs. It's very easy to process and then use as fertilizer. But the solid waste here goes into another separate chamber. This is over. It will be on top of ground, so the sun will hit it, and with time, with the heat, it will break up the solid remains, and that's something that it could be reused. It doesn't form any hazard to people anymore. Again, it's on the level of houses. A little bit more update to it. This is the compost chamber. It's directly making compost. It's after, let's say, 2-3 months, it's full, and then you can take compost out of it, and you keep using it, because when you take compost, it'll make room for like additional waste to be collected. What have been added here, there's a small pipe here, perforated, so air can go inside it and will help with the compost process. You can take it directly, and it's not just waste, it's again mixed with organic material. Here, when things start to get more on the bigger scale, this is a neighborhood scale, and it's very used in this system in Japan, in India. India is one of the leading countries in wastewater management. So basically, it's called a septic tank, which is an update to all the systems that were mentioned before. So basically, the water comes in from the inlet. Water goes down, the solid waste will settle down, and then on the top, the scum layer is basically all the oil, all the soap, all the non-organic waste that floats on the top. It stays on the top, and the solid material goes and settles on the bottom, and then goes to the next chamber. And also, if anything needs to be settled, it settles in the next chamber, and then it goes out through the outlet. So from this system, it takes black water, basically everything that is coming out, and then out of it, the water that comes out, it's good. It could be used for irrigation, but only in systems that drip irrigation, or if it's underground irrigation. So because it's still a little bit harmful for people. And the sludge and the solid waste that is settled down, it will be later pumped out, and also it can go through a separate treatment process that will make it reusable for farming. And then the system is good itself, but there is ways to make it more efficient and make it more usable to connect more houses. Basically, in the aerobic buffer reactor, we just added more chambers, so the water will take more time to go through the tank, and during that time, it's being there is good bacteria that is in the water that will make this interactions that will break up the waste and make it useful to, like, the water will be more clean for irrigation, and the solid waste is also being broken up, so it's easier to reuse. And there's more ways we can push this forward to make it more efficient and effective in terms of space and the amount of water. It's called anaerobic filter, and anaerobic is mean تفاعلات لا هوائية, which is the bacteria working within the absence of air, basically. So again, the water is going through the system, but here we added more like stones, rocks, and pieces of bricks that makes these surfaces, the bacteria can use it to grow on, basically. And it will give it more time to, and more bacteria in general, to digest the waste, the waste and the water and everything. So it makes the water a little bit more cleaner also. And it's very common in places like Japan and India, not just developing countries or post-war or post-crisis. And these are much, much cheaper to make than to have a regular sewage system. And we will talk about that when we get to it. And now we have the biogas reactor, which is very common to use. And it's basically one of the best uses we can make, especially if we have urine diverting toilets. Basically, we have directly the solid waste, or the solid waste that is collected from other system can be put into the bioreactor, and it will decompose. The reactions will happen, and then we will get biogas that can be pressurized a little bit and used for cooking or for heating or running a small generator. And ideally, we have a main reactor and then the small one, which is basically if the pressure builds up, the material have a place to go in it so it doesn't damage the structure. And then it can be taken out and maybe used in farming or something like this. And now, so these systems we've talked about, okay, at some point, this waste still has not moved. It's still in the neighborhood or in the house. We need to think of ways to move it. And here where we have the transportation and emptying systems. And the first thing, okay, if we have a urine diverting tank, so the urine is going to a separate place, we need jerry cans and small jugs to move it around and to ship it to somewhere to treat it or reuse it. And systems that it's more like a bit and it's just a hole in the ground, and this is a very big problem. It happens but mainly in developing countries in Africa, where you have a person sometimes going inside the bit and just with a shovel is emptying the waste from it, but there is a little bit more mechanized ways to collect it, and just they store it in like some tanks, and then it's moved to what is called a transfer station. We're going to talk about it. But ideally, this is what we are most common with, and this is what we most see is the motorized emptying, which is basically a truck that comes and take the sewage water and just take it somewhere, ideally to a treatment facility, but most likely the truck driver doesn't want to drive very, very long distances, so they will empty it like anywhere they find possible. And here we will we more start to see the impacts of these systems on general infrastructure. So we could have a simplified sewer system. This just takes the wastewater from houses, but does not take storm water or rainwater. So just for houses. It's cheaper to make, but then it's also, we still have, in some places, if the city is flat, this will just, and this system doesn't take rainwater, there's the possibilities of floods and things like that. An updated version could be a solid-free sewer system. In a solid-free sewer system, as you see, we have a septic tank. So the hard waste, the solid waste, does not go into the sewage system. It just stays in the tank. Later, a truck will come and pump it up and take it somewhere for treatment. And just water will continue into the sewage system. This basically means we can have shallower depth the pipes that are used in the sewer system is smaller, so there's some cost savings there, and it doesn't need there's some cost saved in the maintenance process also as well. But usually what we have is the conventional system that takes everything. It's expensive to make, and it's centralized, so usually it's either goes to somewhere out the city where they just let the water go freely into a river or somewhere, or a treatment facility. But here is how we can integrate those systems that we've talked about that will make the process of making an infrastructure and the general sewage system for the whole city makes it a little bit more cheaper. And as I said, like if there is, in some cases, people are manually emptying the waste, it goes to a transfer station. They just put it there for, I don't know, maybe a year, 6 months, depending on the usage. Then a truck will come and empty it and move it somewhere else. But here now we start going more to the interesting area of things, which is treatment. We got all of this waste, and if we invested in making these systems to save costs in the sewage network of the city, it makes sense to have treatment facilities. And treatment facilities are where small businesses, that's something just the government can do. It's, if we have decentralized systems, it's something that not small businesses, medium-sized businesses can do. And there is some good money that can come out of it. But let's go through the steps. The first thing in any treatment process will be to remove basically gravel, sand. There is the grease trap, and grease trap is one of the most important things after we emptied, like we took the solid gravel and sand out of the flow that is coming to the system. The grease trap, basically, as you can see here down on the left, is the inlet comes in, and the water goes down from here and then goes up. And in this process, any oil and gas will go to the top, and then it can be cleared and on regular basis. In some area, you can have basically add a compressed air pipe here that will just mix it, drives more fats and oils to the top, and clear all the grit out of the wastewater that's coming to the system. But ideally, in a big plant, there will be the first step when the water comes and it cleared the first step. Here we will have a settler tank, which basically, okay, all the solid waste will settle down. That could be took separately and then goes to its own separate treatment process, and the water just goes out and it goes down its own separate treatment process. Now there is a lot of ways we can treat and basically the waste that is coming in. This is one of them, which is not that much used. It's a little bit complex. It's called Imhoff tank, which is basically, okay, we put a new layer of water or waste that is going through the center, and then it settles down and it goes to the main chamber where we have compressed air, where we can see the reaction happens here. The scum will, any remaining soap waste or oil, it will go to the top. And every once in a while, we can take also the sludge and it goes to the next process. And what we've talked about them, the anaerobic reactor and filter, they are basically not just storage systems, because they are already starting treating the wastewater that's going in, and it's just makes very sense to have it. Okay, it's inside the neighborhood, already treating the water. The water after this tank, there could be something very small like a UV treatment light, which is just basically this size as like a UV light that will clear any remaining bacteria and germs in the water, and it can be used directly in irrigation. But more, like say, older systems that they would require more space to make, but in the same way they can handle more wastewater coming through them, was the stabilization points, where we have, okay, the first step, everything is coming through this inlet, it starts to settle, and then the water goes out, it goes again through the same process and again through the same process. But here this time we don't have anaerobic bacteria أو جراثيم هوائية. It's aerobic reactions and aerobic bacteria. So عناصر تفاعلات هوائية. This is how the waste is being broken down. And anaerobic reactions actually help reduce the smell of the waste. And here is another way just to make the aerobic reaction happen faster, is actually you just add like fans that just mix more oxygen into the water, so the process can go a little bit faster. And here we can see direct application into farming. Before, we can use farming as a way of treatment. So we have different, they're called stabilization ponds. Constructed wetlands. And there is a few types for them. And basically, constructed wetlands, we can grow things like corn, for example, sunflower seeds in them directly. The wastewater comes in, ideally after it went through a septic tank or an anaerobic reactor. So the water will go in, goes between the roots of the plants. It helps remove any smell remaining, and at the end of it, okay, there is also an aerobic reaction happening. So the bacteria is also like good bacteria is also growing and taking away all the harmful bacteria. And then the water, because we have huge amount of water that's going through it, at the end there will be more water that is left, and then it can be further used in other places, and it has the good, it doesn't have the bad smell anymore, so it can directly be used. So there is different types. The ones on the left both take the water after it has went through an anaerobic reactor or a septic tank, so it's a little bit more clean. It doesn't have that much solid waste in it. But the one on the right, which is free water surface, it takes directly the water with everything. There will be, like with time, there will be a layer of waste material that has to be scraped, and then we plant again, and so on. In some cases, they're used without even having something planted in them. They just fill shallow surfaces or shallow tanks with wastewater. They wait for it to dry, and then they just break it and use it in composting. And what we always think of, which is the trickling filter. This is when we see in movies or online or somewhere, you see these big ponds with a filter just rolling around and dropping water. This is very common, and it's something more centralized. This is used on city level treatment, so it's very expensive to build the whole system. There are more ways to treat, but they are less common. So basically, we have the tank that is filled with the wastewater, and basically air is pumped through always. So through the bottom, the flow comes with the wastewater mixed with air. It goes here, it stays for a while, then the water can go out. There is biogas that happens through this system, so it's also good if you want to collect the biogas and use it in something. And then there is here, it's called activated sludge, basically. So it's a little bit It's not complex system, but it's a little bit harder to run and maintain over time because there is air compressors that are bringing in water. So basically, from the inlet, the wastewater, everything is coming, and then air is being pumped constant, like all times through it, to keep the reaction going. Then after that, it goes to the next tank where it's okay. The solid waste will settle in the bottom, water will stay on the top, and it will go out. And if sometimes, okay, they take a sample, okay, see, has it reached a good level that is safe to dispose or reuse, or do we need to also go again through the system again? So it could be directly taken back into the system to go through another round of treatment. And here, as I said, there was this, they're called thickening bonds, where you just, the trucks that collect waste, they will just come, pump, empty it, just leave it till it'll dries. Water will slowly go out from the outlet here, but okay, it stays until it's fully dried, then it's broken down and disposed of. And these are drying beds that also, as I said, like this is a planted drying bed. The truck empties everything, the water will slowly go down to the bottom, and then we can take it and reuse it somewhere else. But every few cycles, let's call them, it's cleared and then planted again and then used again. And there is unplanted drying beds, which is, as you can see, the truck also emptied everything. There is a bed of stones and grit, so the water will slowly go through it to this outlet, and then we can take the water and further treat it, or we can, and the sludge that is on top is, we just wait for it to dry, and then it could be goes through further treatment, or could be safely disposed. And the very common thing is co-composting. So we got the solid waste that came out of any of the systems. We can just bring it, mix it with organic material. It will make a compost that is safe to use as a fertilizer for plants directly without anything, because during the composting process, the temperature will rise a lot. So it will kill all the bacteria in it, and then it can be used for composting. And as we mentioned, the biogas is not just a containment, also it's a treatment solution. As I said, okay, the solid waste is going through it, it decomposes, and then the biogas is taken out and can be reused, and the sludge can later be moved into farming. And here is, after all of these steps, we can bring the water. The water will go through a final step, just to clear it at the end of the line. It goes through also grit and stones to filter anything out of it, and then the water goes through either some chlorination device, which just makes chlorine with the water, or it could be a UV light that kills any remaining bacteria. But after these, we have to think of end use, what will happen, and disposal. So ideally, if we are using the pit systems, after we finish it, it's safe to plant a tree. The tree will use the waste as fertilizer, and it will grow, and we just move our toilet somewhere new. And urine is, as I said, ideally it's sterile. It does not contain any germs for a healthy individual, at least. It's not directly applied. It will be put in a storage tank for a while. It will break down and be much more beneficial to the plant, but not in direct sunlight. So it's kept in a tank that is basically black. Sunlight and light cannot go through it. And after 2 weeks, it can be reused directly as a fertilizer. And dehydration involved, as I was saying, the heat from the sun over time will kill everything in it. So we can take the sludge and directly use it for as a fertilizer. So any system that is the solid waste was mixed with organic material, over time it will decompose into something that we can. It's a compost basically. We can use it directly as a fertilizer in farming. And in some cases, and this is basically the worst case, that it's very common, especially in Iraq, they will bring it directly from the houses with the solid waste, just put it in a settling tank so the water will go out of it, and then they will just directly apply it for the entire farm. It is usable, it's okay for certain crops, but usually it's not. It has to be done very carefully so no germs will affect the fruits and vegetables that are grown in these fields. And for irrigation, it's usually, as I said, we like drip irrigation because especially if there is no like a chlorine station at the end of the system or UV light, it's okay. The water is directly, we can use it in farming. It just has to be through drip irrigation or some system that is underground. And this is also can be used on a house level. So after some type of containment that we have, the water is coming out. The water can go into a soak pit, basically just a small bit in the ground, so the water will like slowly trickle through the surrounding soil. And also on the house level, it can be, as I said, like a septic tank. There is a leach field after it. The leach field we could plant on top of it. It's fine. It will be an irrigation system at that time. But if someone does not want to farm anything, it's basically a leach field. And the biogas and the biomass that is generated can power like a stove for cooking or a small generator for lighting. A small generator, depending on the size of the system, it could be a small generator, it could be a big generator. And for the water, that comes out of the system also, other than irrigation, it could be used for aquaponics, basically for growing fish. It could be used for hydroponics, and it works perfectly. There's nutrition materials for plants to grow and use. It's a very good solution. And also in some cases there's a few types of fish that can grow in it, and later we can harvest the fish and use it. And the last thing, it could be just okay, the water is safe to dispose of. It goes through a nearby river and then it goes through the nature. And in some cases where everything is safe, we can just store it, the solid waste that has been treated. There is no use for it. We can store it at some places. It can stay for years. So yeah, that's basically it on wastewater management. If anyone has any question, now is the time. Okay. If there is no questions, so let's just briefly and quickly talk about hydroponics. I just wanted to mention it here, and vertical farming, because I've done some work around that, and I can share with you a small, not the full report, just a few points of things that we have done also around wastewater management. So hydroponic, which is basically a vertical farming technique. It saves space. That's a very important point. It's water-based farming, so we just need to add nutrition to the water, and the water we can keep cycling and reusing. Some of its advantages, it can be used at anywhere. Just instead of just having the greenhouse, that's just one floor, let's call it. We have one crop growing inside it. We can have, as in a vertical farm, we can have multiple things growing there, especially in dry places. I've seen in Dubai, basically, people that have started small businesses that are doing this. It needs to be a controlled environment, and we control the pH of the water. So we make it sure it's the perfect environment for growing that plant, so we will have the highest yield possible out of the crop. It also doesn't need that much water, even though it's water-based farming and there is no soil in it. But since it's a closed system and a closed loop, so there is no water going through groundwater, there is no water that's being evaporated by sunlight or anything. So it's just a closed system, so it doesn't need as much water as regular types of farming. Also, we have a higher growth rate for the crops we are growing, since it's the ideal setting for them and the ideal environment, so it's faster to grow, and especially if we're putting fertilizer and nutrition materials, so we can have multiple crops throughout the year. It also helps with the soil degradation, so we're not affecting the local soil in this area, so it stays good for the future generations to use it. It's also tricky. We don't need to do if anybody done like worked on a farm before, let's say every year you have to make if this year we've grown wheat, next year we should grow, let's say, hummus or something like that, because that plant will help the soil recover some of its nutritious value, and then for the next year we will have a different crop, and so on. With this system, we don't have to do this rotation, so we can grow the same crop over and over and over without any harms to the soil. And these are just some ideas. It's been used as a decorative system. It's used on large scale as a farming for profit by companies. There's some things that are on a house level that can be used. The only trick with it, it's someone that has to be either the system is programmed or controlled by computers to monitor the humidity level, the heat inside the structure, and the amounts of nutritious material in the water and the pH of the water, so it stays within the perfect range for the plant, because if there is any changes or any mistake, it could actually lead up for basically losing the whole crop that we have and all the plants that we have. Okay. Also, I will open it for any questions for anybody if they want to discuss. If no, I will just briefly talk about the report and some work we've done with on wastewater management. So during my work on Treatment Hub and with an organization called SEWAS, we got contracted to do an needs assessment report in a small town called Qushtaba. It's in Erbil government in Iraq. Before I talk about it, I just wanted to show you here. If you see, if you see this area here, it's green. You will expect there's a river there or something, but no. It's all the water and the sewage water of the whole city, which is roughly, it has 2 million people in it. It just goes emptied here by the sewer system and by the trucks that collect wastewater, and it's just emptied there. And along it continues all the way to the Euphrates, to Dajla, not. And along it's all farms, and people directly use the water from it on the vegetables that they are growing, and then the vegetables are sold inside the city. So there is always many cases of people that are basically have food poisoning. So more about Qushtaba as a city that we've worked on. Qushtaba is around 23 kilometers outside of Erbil. It's a small town. It only has 3,600 inhabitants, and there is 1,900 family close to it in a refugee camp. And basically, it's a very important thing to see when we are making this system is the groundwater level. So before 10 years, it was around 75 meters. So if you dig a well 75 meters, you will get water. Now it's all the way down to 300 meters. There is no, as you can see, like in the middle of the photo, there is that water is basically the water coming out from the houses from washing and showering. But the solid waste, only the toilet, it goes to a small hole in the ground in each house. Sometimes it's constructed, sometimes it's just a barrel in the ground or something. Those type of things, but it's not managed anyway. The government, since it's a small town, there's no budget, nobody cares about it, so just, they leave in it like that. Most houses use bits in the ground. It's called a cesspool, basically. And it just collects يعني الجوار الفنية اللي نحن بنعرفها. So it just collects the waste, it's there. And some houses every year they empty it, but the average was people empty it every 3 years. They call a truck that comes and just empty the bit. And this is here us, we were going around and asking questions, and you can see from his reaction, the guy in the middle, you can see like, why are we asking about toilets? But basically that's what, like, we were asking about toilets, how many times, what type of containment basically do you use? Do you have a cesspool, a pit, or whatever it is? So they would just get confused, like, why are you asking these questions? And yeah, that led us to a few challenges. People were, why are you asking about my bathroom? And they stopped the conversation. They didn't answer any of our questions. Some people did not even know, okay, like we have a hole in the ground and that's it. We don't know anything else. We don't have any more information. And since the whole city is basically relies on those trucks to come in and just empty those those cesspools, nobody, like most people would say, like, do you have the phone number for a truck that comes and does this? He said, no, that's written somewhere on a wall. You go, you call the number, nobody's there. But it's just someone wrote a random number. So also, so this is basically talking about difference of the containment they have. Most people, they have different cesspool. It's either perforated, it's open from the sides. That is really hard to empty with a tank, with a machine, because it might collapse and break. Some of them are open bottom, and which basically, if you use a machine, that's fine. Some of them has, what they have is pit latrine, so basically just a hole in the ground. Some of them has made like a vault. It's just closed from all sides. It's filled every year, and people just usually empty it. But these are the trucks that people use. So ideally, you will have the information about these. But okay, there's a truck that is owned by the government that it's just parked. People like the employee take salaries and they don't do anything. But there is a private-owned companies that actually cover the needs of the village. And at the end of it, we found out it's out of control. Nobody cares what's happening or how that wastewater is being treated or collected. There was an interest from a farmer, actually, who has some money. He said, okay, that will be great if I can do this system and I can use it for fertilizer, to use it on my soils, to just save costs, basically. Because what we found out is most of these farms around the village, they not only the trucks that you work and collect waste from the houses in the city, even from Erbil, from the city, they call them, they pay them money to come and empty this wastewater this in their farms and just directly use it as fertilizer for their farms, which is very, very dangerous. And it's last year, I think, for 3 months, it was banned, all the restaurants, everyone, to use vegetables, because all the farmers have used wastewater to water their farms, and everything was contaminated with germs, and basically it was banned to use vegetables in restaurants for 3 months. Any questions right now? It's open for you and for discussions.
Hi, Yosef. Thank you very much, Yosef. I mean, it's super useful, detailed, and helpful for us, actually. And that's what we need, and that's what we are looking. Because, I mean, usually as architects, we are not looking, or we are not going with these details. We just like, as we did, like, for example, in our proposal, okay, let's do this and put it this, but we didn't go with the technical, let's say, technical drawing, technical stuff, the way how it's working, the way how we want to reuse it. The reuse these things also is super important for us, and that's what I saw in what you have so far. I mean, you have a lot of information and you have a lot of detail, and I think it's also like if we do like more and more lecture about that, also would be useful for everyone. I think yes. Thank you very much. For me, I don't have the question. I would like to open it for everyone. I mean, like to discuss it, especially also here. We have some guests and we have from our team. Thank you, Yosef, anyway.
You're welcome. It's my pleasure. So yes, like I've seen a lot of businesses make a lot of money from just the treatment and reuse of material. But
Okay.
I didn't want to put any photos or videos because it's yeah, not everybody would like to see those photos.
Exactly.
ليست لأصحاب القلوب الضعيفة.
حدا عنده سؤال؟
مرحبا، يعطيكم العافية.
الله
يعافيك.
يوسف، أنا بس عندي سؤال إنه من وجهة نظرك أو برأيك إنه which system هو اللي حيكون إنه أكتر شيء suitable للكيس اللي نحن عنا بالديزاين كماستر بلانينج. إذا نحن عنا كذا يونت على الشيء اللي نحن عم نشتغله، إنه برأيك شو هو أكتر سيستم عملي واقتصادي ويعني مفيد لنا ممكن نعتمد عليه أو نتجه له يعني؟
لحظة خليني نرجع أعمل شير سكرين. اللي أحسن شيء واللي شفته يعني كان مطبق بمخيم اللي هو اناروبيك فلتر، لأن المي عم تجي في بس جريس تراب مشان يصفي الزيوت والصابون والقصص هي منه، وبعدين عم تروح بالسيستم هذا. فهو الإنشاء تبعه بسيط جدا، وخلص في يعني في حجار او كسر بلوك او اي شيء هن اللي عم تصير فلتر ماتيريال والبكتيريا
تماما
الموجوده
يعني مع
اساسا.
الجريفل. اوكي
تمام. والمي بس تطلع منه يعني هون في عندنا اوبشنز نحن حسب شو في مصاري. فينا نعمل فيلتك صغير مزروع فيه شويه نباتات مشان تقضي على الريحه، مشان ما يضل في ريحه سيئه بالمي. وبعدين في شيء اللي هن يو في لايت، يعني ما بعرف شو اسعارهم بالضبط، بس هو كجهاز حجمه كثير يعني حجمه صغير، يعني خاص المي بتمرق منه بثواني. اليو في لايت بيقتل اي جراثيم بعد باقي فيها، والمي فيها تروح للزراعه مباشره او مثلا للحد